Hello everyone and welcome to the last video of the experiment tracking module. This video is about MLflow in practice. Let's consider different scenarios for running MLflow. In the first scenario, there is a single data scientist that is participating in an ML competition. On the second scenario, there is an entire cross-functional team working on an ML model, but only one data scientist is building this model. And in the third scenario, there are multiple data scientists or multiple members of a team that are collaborating to build multiple ML models. These three scenarios have different requirements. For example, for the data scientist participating in the ML competition, having a remote tracking server will be overkill. She doesn't need to keep track of the runs remotely, and saving this information locally will be enough. Sharing this information with others is not a requirement. And also using the model registry is useless in this case because the data scientist is not interested in deploying this model to production. On the second scenario, the cross-functional team has the requirement of sharing the experiment information. But there is not necessarily a requirement of running a tracking server remotely. So running the tracking server locally on the data scientist's computer could be enough. Also, using the model registry would be a good idea to manage the lifecycle of the models, but it's not clear if we need to run it remotely or on the local host. Finally, on the third scenario, sharing the information is very important. So the data scientists are collaborating to build the models. So maybe one data scientist will launch an experiment, add some runs, and then another data scientist can continue exploring hyperparameters and different models to add even more runs to these experiments. They need to run a remote tracking server. Also, when it comes to the model registry, it is very important to manage the life cycle of the models because maybe there are different people that are in charge of building the model and deploy the model. So as you can see, depending on the context, you may want to configure MLflow using a different setup. To do that, you need to think about three main aspects. The first one is what is the backend store of MLflow. So the backend store is basically where MLflow will save all the metadata about your experiments. That means the entities like metrics, parameters, tags, and this can be saved into your local file system. By default, if you don't configure a backend store, MLflow will assume that you want to save all this information locally, and it basically will create a folder in your local file system and store all the information about your runs on this folder. Alternatively, you can use a SQL Alchemy compatible DB for this. For example, I showed you before how to configure a SQLite DB as the backend store, and this enables you to use the model registry. Then you need to decide what artifact store you want to use. And for this, you can also use your local file system, which is what MLflow will assume if you don't configure an artifact store. So all the models and artifacts will be stored locally in a folder in your computer. The second option would be to have a remote artifact store. For example, you can use an S3 bucket for this. And finally, you need to think if you actually require to run a tracking server or not. So the first option is not running a tracking server, and this will be enough, for example, for the data scientist that is competing in an ML competition. On the other hand, if you decide to run a tracking server, this can be run locally or on a remote host. Let's go to Visual Studio, and I'm going to show you some examples about how to configure MLflow to satisfy different requirements. Okay, we are back to Visual Studio. Let's go to the Explorer, and here I'm gonna open the folder 02 experiment tracking, and inside here running MLflow examples. Let's go with the first notebook. In this notebook, we will explore the first scenario that we mentioned before. So there is a data scientist that is participating in an ML competition. And for this scenario, the setup for MLflow is quite simple. We are not going to launch a tracking server. And for the backend store and the artifact store, we plan to use the local file system. That means that all this information will be saved locally in a folder. And then if you want to check the experiments for this MLflow instance, you can just explore them locally by launching the MLflow UI. I will show you how to do that. Let's execute this. So here I'm importing MLflow, and as you can see, I didn't specify a tracking URI. So by default, MLflow will assume that you, in this case, you want to use your local file system to store artifacts and the metadata about the experiments. And we can check that here. I'm basically asking MLflow what is the tracking URI for this instance, and MLflow will tell me, okay, this is a file in your local file system. Actually, it's a folder called ML runs. So these are some assumptions that MLflow will do if you don't specify backend stored and an artifact stores. The folder wasn't created actually here. If you check inside running MLflow examples, we don't find this folder ML runs. But as soon as we start interacting with the MLflow instance, it will create it. For example, I can list experiments, and now, yes, you can see this folder ML runs was created. Yes, MLflow is telling us that there is only one experiment, which is the default experiment. Remember that every time you start using MLflow, there will be a default experiment, and if you run some MLflow code without specifying the experiment name, those runs will be associated with this default experiment. And here inside ML runs, you can find a folder with this name 0, and this is basically how MLflow stores the information about the experiment. There is this meta.yaml file, which contains the name of the experiment, the ID, and the artifact location. Let's continue now. And for that, I created this code that trains a logistic regression model on the iris dataset. And for this, I'm setting the experiment to this experiment name, my experiment 1. This experiment doesn't exist, so we checked before there is only one experiment, which is the default one. In that case, MLflow will create the new experiment, right? And then remember, this code is basically a toy examples, which is logging some parameters to MLflow, is training and making predictions with logistic regression on the same data, because this is just a toy example. And then it's logging only one metric, which is accuracy. Finally, we will log the model here to this artifact path, and we're going to ask MLflow where these artifacts are being stored. I'm going to execute this, and after 2 seconds or almost 2 seconds, we can see that yes, effectively the experiment was created by MLflow because it doesn't exist. And when I asked where are the artifacts being stored, it's also pointing to my local file system. We can check that. Actually, now if we go to ML runs, we can see that there are 2 folders. The first one, remember, is for the experiment with ID 0, which is the default one, and the second folder is for the experiment with ID 1, which is the experiment that I just created. We can check that by expecting this meta.yaml file, and yes, the name of the experiment is my experiment 1. Inside here, you can find another folder. This is the folder that MLflow created because I executed one run on this experiment. If I execute this code multiple times, then there will be more folders inside here, one for each of these runs. And for each run, you can find these artifacts here saved. Again, this is save it to your local file system. You have the metrics. There is only one metric, accuracy. This is just a file, right? With the value of the accuracy. Then parameters, there are 2 parameters that I logged, and some tags that automatically MLflow will save for you. So all information, artifacts and metadata about your experiment are being stored to your local folder, and you can see a correspondence between each line here, right? For example, when you set the experiment to this, MLflow will create the experiment, and that means that there will be a new folder inside ML runs. When you log a parameter and start a run, MLflow will create a new folder for this run and will create a folder params and store the values of the parameters that you were logging. And when you log a metric, the same thing happens. There is a new folder for metrics and then file for the metric accuracy. And when you log the model to this path, then MLflow will create this folder artifacts, and then inside another folder called models, and inside MLflow will save your model. So let's continue now. If I list the experiments, I can see that now there are 2 experiments. And finally, let's try to access the MLflow model registry. This won't be possible. Actually, here I'm catching an exception, which you will get if you try to execute this line, because as I told you before, it's not possible to use the model registry in the case that you are using your local file system for the artifacts and the backend store. Actually, the problem is the backend store, but that can be solved easily if you use a different backend store like a SQLite. And before moving into the next scenario, I wanted to show you how to explore these runs in the UI, right? Remember that we are not going to run a tracking server, but still we can access this information. And for that, let me go to the terminal. So I'm going to go to repository, MLOps, and 02. Okay. So now I'm here in repository MLOps Zoomcamp and on this folder 02 experiment tracking. I'm gonna activate the conda environment, and now I'm gonna run the MLflow UI. So the MLflow UI is now running on this address. Let's go to Chrome. Okay, sometimes you will see that when you try to open the MLflow UI, takes some time. This is expected sometimes if there are previous runs of MLflow. So here we can see that the MLflow UI has opened, but there is no experiment one, right? Only the default experiment. This is a common error. Let's go back to the terminal. The problem is that we are launching the MLflow UI in a wrong folder. You can see here I'm running it from this folder 02 experiment tracking. So let's stop this. And what happened is that MLflow assumes that you want to run your experiment locally, and it has created a new folder, ML runs, inside this folder 02 experiment tracking. But actually, I wanted MLflow to check the artifacts inside this folder, right? Running MLflow example, which is where I executed the notebook scenario 1.ipnb. So I wanted MLflow to check these runs. So for that, you can just easily solve it by moving into this folder. And now we'll run MLflow UI one more time. Let's go and check the MLflow UI. This is another problem that you will face if you try to access this server. Yes, you will get an access denied. You can try again, it won't work, but then you just need to go to settings of your web browser, privacy and security, and clear the cookies. So clear all the data from the last hour. Now let's reload this. Now we can see the MLflow UI, and here you can find the experiment one that we created before. So everything looks fine here. Here are the two hyperparameters. The metric that I logged was accuracy, and even the model was possible to visualize from here. Okay, so let's go back to Visual Studio now, and I'm going to delete this folder ML runs. Remember that this was created when I launched MLflow on the wrong folder. So I'm gonna just delete this one, and just to avoid problems with the next scenario, I'm gonna also delete this folder ML runs. I don't plan to keep this information anyways. Okay, so now we can go with the scenario number 2. In this scenario, remember that we are assuming that there is a cross-functional team and there is only one data scientist that is working on a ML model. So what I mean with cross-functional team is that the team has different roles. So the data scientist maybe has to interact with backend developers or front-end developers, or maybe with the product manager, and at some point showing them, what is the progress of their work, how the model is being built. So in this case, we probably want to launch tracking server, but launching it locally could be fine. For the backend store, I would say you should use a SQLite DB or any other DB that you want to configure, because this will enable using the model registry. And for the artifacts store, using local file system will be okay. But if you want to save this on the cloud, that will be also good, because other people can access these models. And the experiment can be explored locally by accessing the local tracking server. The benefit also of running the tracking server locally is that if you have a long experiment, let's say that you are exploring different hyperparameters for a model, and this experiment will take a few hours, then if you have a local tracking server, then you can see how these models are being trained and what is the score. You can see this in real time, right? So the runs will be added on real time to the experiment, and then you can see the results before the whole run finishes. For this scenario, you will need to run the MLflow server locally, and you just need to do this MLflow. So copy this command and let's execute it in the terminal. I'm gonna stop this. Again, I'm on this folder running MLflow examples. and I'm gonna run the server. This is not the UI, this is an actual server. And for the backend store, remember I'm using a SQLite DB. In this case, MLflow is complaining because I didn't specify a default artifacts root. Let's do that. And instead of ML runs, I'm gonna set a different name. So maybe artifacts local would be fine. And yes, the first thing that MLflow will do if you launch the server this way is to initialize this SQLite DB. And you can see here that it's doing that, okay? It's creating initial MLflow database tables, updating database table, and so on. And then the server was launched on this address, okay? So remember that this is the address in which MLflow is running the tracking. So in this case, I'm setting the tracking URI to this address. So MLflow will use the backend store and the artifact store that was configured for this instance, for this tracking server. So I don't need to specify here the backend store again and the artifact store. And we can check that. So if we ask here, the tracking URI, it says that is this address, which makes sense. And then when I list the experiments, I can see that the artifacts location is this local folder, which is what I configured for the tracking server. And if we check here the files, we can see that there are two new files. Actually, there is this backend DB, which is the SQLite DB that I configured for the server. And then there is this artifacts local, which is what's created by MLflow to store the artifacts for all the runs. Let's continue with this. I'm going to execute this code. It's the same code that I showed you before. It's saying that the artifact will be stored to this address, to this path in my local file system. We can check that actually, artifacts, and yes, here you can see that the artifacts actually only the model that I created is being stored here, but the metadata about the model is not here. Sorry, the metadata about the experiments is not here, right? That's because MLflow is using this backend store to store the metadata about the experiments. That means the metrics, the parameters, the tags, and so on. Okay. Now I'm going to list the experiments. There are two experiments, the default one and the experiment that I just created. Now let's try to access the MLflow model registry. List the experiments, list the registered models, and there are no registered models. And finally, we can register one model. So here I'm basically getting the information about the first run of the experiment with ID 1. And then I'm pointing to this model URI, which is the run ID and the path models. And then I'm gonna call this model iris classifier. And MLflow is doing basically what I asked it to do. So basically is registering a new model, which is iris classifier, and adding the version 1 to this model. And this is the only version that is available so far. Let's check how this looks like. So for that, we need to go to Chrome. Okay, if I try to launch this again, I'm gonna get this access denied. But let's delete the cookies. Yes, clear browsing data. And now I'm gonna reload the page, and I can find here the experiment ID 1 that I just created, and actually the model was registered to the registry. All the information as expected, parameters, metric. And regarding the model, I cannot register the model because it was already registered. If I click here, I can access, right? There is the model registry. There is this model iris classifier, and only one version was created so far. Okay, let's move on with the last example. First of all, I'm gonna delete this file. So the third scenario, remember that we are assuming here that there are multiple data scientists that are working on multiple ML models. In this scenario, there is a requirement for sharing the information about runs and experiments. Maybe one data scientist will start working on the model, and maybe generate some runs, and then another data scientist can continue exploring the modeling alternatives, tuning some hyperparameters, or maybe trying a different model or different data set. Likewise, maybe there are some data scientists in charge of building the model, but then a different person is in charge of deploying this model, so using the model registry is also a requirement for this scenario. In this case, I decided to go with a setup in which we're gonna use a tracking server, but this server will be launched remotely. So I'm gonna use EC2 from AWS to launch a remote server. For the backend store, I'm gonna use PostgreSDB, it's not SQLite So this is an error. And finally, for the artifacts stores, I'm gonna use S3, so also from AWS. The experiments can be explored by accessing the remote server. I'm gonna show you how. And yes, for this example, we are going to use AWS to host this remote server. So if you want to run this example, you will need to have an account, an AWS account. You can create one and follow the steps described in this file, MLflow on AWS. We explain you how to create the account and how to launch and configure the tracking server. You can find it here also inside 02 experiment tracking. There is this file. So this is in Markdown. Here we explain right how to create the AWS account. If you create a new AWS account, you can access some of the products from AWS services for free. This is called the free tier. There is always an option depending on the product. Some of the products are not included in the free tier, but for some products like EC2 and also RDS for the databases, you can access some instances that you don't need to pay. At least you have a quota, like for example, in the case of RDS, I think that you have 750 hours per year or per month, I don't remember, and you won't be charged for that. But yes, of course, this is a service, it's a paid service, so take into account that you may be charged if you follow this tutorial. Be sure that you understand how this free tier works. You can read the information here in these two links if you want to understand more. But I'm assuming that you have some knowledge on AWS in order to avoid being charged for using the services. So here are the steps, right? First, we're gonna launch an EC2 instance. Then we need to create an S3 bucket to store the artifacts. We're gonna create a PostgreSQL DB from RDS to be used as the backend store, and then configure this. And finally, we're gonna connect to the EC2 instance using SSH and launch the tracking server there. We will install all the dependencies and launch the server. And finally, you can access the tracking server, the remote tracking server from your local machine. And I'm gonna show you how to do that. Now let's go to Chrome. You need to go to EC2 and launch a new instance. So this is the EC2 console. Here you have an option to launch a new instance. For this, let's call it MLflow server or MLflow tracking server. I'm gonna use an Amazon Linux 2 operating system, which is free tier eligible. So that means that it's included in the free tier. There are other options, like for example, you have this one. You can also use Ubuntu if you want, but for this, let's choose Amazon Linux 2. And then for the instance type, I'm gonna use the T2 Micro, which is also free tier eligible, but there is other option, for example, T1 Micro, which is a smaller machine. And then you will need to create a key pair. For this, you just click on create key pair. And here you can put, for example, MLflow key pair. I'm gonna create an RSA encrypted private key and public key. And I want to save it using this format, .pem. Click here and then it will download this key pair. I have already created it, so I'm just gonna use the one that I created before. And this is required because later we will connect to this instance using SSH. So to log in into the machines, you need the key pair, right? These are the credentials that allows you to access the EC2 instance. The rest of the configuration can be led with the default values. And now I'm gonna launch the instance. This is gonna take some time. So the instance was already launched. You can see here that it's in state pending. So this is going to take some time to fully launch the instance. We can already explore the instance. If you click here, and the first thing that we need to configure in the security here, you should find, yes, the security group. You can see that this security group was created automatically and it's called Launch Wizard 6. If you click here, you can see that there is only one inbound rule here that allows connecting through SSH. So this is needed to access the machine. But I'm going to edit this rule and add a new rule so we can connect also through a HTTP connection. So here I'm going to create a custom TCP in the port 5000, which is where I'm planning to launch the MLflow server. And I'm going to allow access for any IP. You can configure it to accept connection from any IP or from IP version 4 or IP version 6, or even if you want to restrict the access, you can select your own IP. So the instance will be only accessible from your local machine. But I'm going to use just allow connection from all the IPs. I save the rules. And if we go back to the dashboard, instances, okay, we can see that this new instance is already running. All the details about the instance can be accessed here. So the next step will be to create an S3 bucket. And for that, we need to go to S3. This is the S3 console. And if you click here, you can access the buckets. So there are no buckets so far. I'm going to create one. I'm going to call it MLflow artifacts remote. Take into account that here you can read the rules for naming S3 buckets. There are a few rules that you need to follow. For example, the bucket name must be between 3 and 63 characters long. One important thing that you need to consider is that the bucket names must be unique across all AWS accounts in all AWS regions. What it means is that if you are trying to create a bucket on the same region, you won't be able to create the bucket with this name because I already took it. And actually, I guess that if I try to name it MLflow, it will complain because I guess that somebody else already created a folder called MLflow. Let's try it. Yes, so we can see bucket with the same name already exists. But if I'm lucky enough, nobody created a folder called MLflow artifacts remote. Let's create it. Yes, I was lucky. Remember the name of this folder because you will need it later to configure the server, right? So I'm gonna keep track of this in my notes. And now let's move on to the next step, which is creating the Postgres SQL DB. For this, we need to go to the RDS console. Okay, so if I click here, I can create a new database, but okay, not from here because this is a multi-AC deployment. I just gonna create a database here. I'm gonna select the standard create. Here I want a Postgres SQL DB. Here you have the templates for free trial. And then the name of the instance, I'm gonna call MLflow database. The master username, I'm gonna use MLflow, just MLflow. I'm gonna ask RDS to create a password automatically to generate a password because I don't want to think about the password now. And here you can see that there are only two instances for this DB that are available are the T3 micro and the T4G micro. I'm okay with this one, so I'm gonna continue. Storage, this is okay for now. And for connectivity, yes, I'm gonna let all the default values. I'm not gonna allow public access to this database because I only want the EC2 instance to reach this database. So I'm gonna select the default value. For the VPC, I'm gonna use the default VPC because here is where I launch also the EC2 instance. So I need later to update the security group, but at least I know that the DB and the EC2 instance live on the same VPC. Okay, so they can see each other. And then additional configuration, we can see that the port that will be used for this database is 5432. Okay, sorry, I just changed it, but it was a mistake. So this is the default value for Postgres. So I'm gonna add the default value here. I want to require password authentication for this database. And in additional configuration, we need to make a few changes. Here, I'm gonna put the name of the first database. It's gonna be used as the table to store all the metadata about experiments. So you need to specify a name here, otherwise RDS is not going to create the database for you. You need to remember to specify a name here and also keep track of this name because we will need it later. And that's it. I think that we are good with just creating the database. Creating the database will take some time, but we can check maybe a few things in the meanwhile. Remember to take note about the information that I showed you before. One of this information that is important, RDS is telling you here in this message. So it's saying that the database will be launched in a few minutes and that they have already generated a password, a master password for your database. But the thing that you need to consider here is that this is the only time you will be able to view this password. You need to copy this password and save it. So we're gonna click here to view the credentials, and this is the password. So I'm gonna keep note of the username, MLflow, and this is the password I'm gonna copy. And also the name of the database was MLflow_db. Okay, so if we click here, this is still in status creating. So after some time, here in endpoint, we should see the endpoint that we will use to connect to this database and the port, which we already know that is 5432. Here you can find the security group. Remember that we are using the default one, but I want to make a change here. So let's click on the security group. If you check the inbounds rules, in your case, maybe it's different, but let's delete this so you can see. So you probably will see only this rule, but you need to add another rule to allow the EC2 instance to connect to the database. So for that, you need to look for Postgres. Okay, so PostgreSQL. And you can see here that it's gonna access the DB on this port, which is expected. This is the port that we selected for the DB. And here we can select the launch wizard number 5. If you remember, this is the security group that was created automatically when we launched the EC2 instance. That means that the EC2 instance can access the DB by accessing this port 5432. So I'm gonna save the rules. Let's go back to RDS now to see if the database was already created. DB instances is still being configured. I'm gonna click here, but already we can find here the endpoint. I'm gonna take note of this endpoint because I will need it later. And that's pretty much all. This is gonna take some time to finish the configuration, but we can already move on to the EC2 instance and configure it. So if we go to instances here, we can see that there is only one instance that is running. I'm gonna click on this. And here you have an option to connect to this instance. I'm gonna click here. So there are different options to connect to the instance. I will recommend this one, EC2 Instance Connect, which is the easiest one. Otherwise, you can connect through SSH. For this, you will need to use the key pair that we created at the beginning and use this command here to connect to the EC2 instance. So you just copy this and paste it into your terminal, and then you will access to this machine. But I'm gonna just connect from here. This is the same thing. Basically, you would connect to the instance and open a terminal. Okay, so we have just accessed the Amazon Linux 2 instance, and here we need to install a few things. First, I'm gonna run an update on the machine. Yes. Now I want to install a few packages. Let's try to do that. So pip3 install MLflow, Auto3, and this library, which has a name that I don't want to make a mistake. So PyPsycho PG2 binary. So these are the packages that are needed to run MLflow, to connect to AWS, which is the artifact store, to S3, sorry, and also for the connecting to the PostgreSQL. So now, if we try running AWS, so this is already configured and installed, the AWS command line interface here in this instance. So we can access, for example, we can list the buckets that are available for this account on S3. We're just running AWS S3 LS. So we got this error. It says unable to locate credentials. You can configure credentials by running AWS configure. So let's do this. AWS configure. You will need to input your AWS access key. Later, you will be asked also to input your secret access key. So let's do that. So secret access key, then a default region, you can let this unchanged, and also the output format, you can also let the value unchanged. Let me just configure that. 1 second. Okay, I just configured the instance with my credentials, and now if we run AWS S3 LS, we can see that the S3 bucket that we created before can be accessed from this, and actually we can list the objects that are available in this S3 bucket. In this case, the bucket is empty, so we are not gonna do anything. The next step will be to run the server. For that, let me just copy this and paste it. So yes, there are multiple things that you need to change from this. First, if you remember, here is PostgreSQL. This is an error. I need to change this here. Now you need to change the DB user. I ask you to take note about this. In my case, I configured this name, MLflow, for the user. The DB password was created automatically by RDS, and I copied this here in my notes. I'm gonna paste it. The database endpoint, also remember I asked you to take note of the endpoint. In my case, it's this one. And the DB name, remember it was MLflow underscore DB. And finally, for the artifact store, remember that we created this bucket. Okay, so we can execute this, taking some time. We have the DB is not ready yet. Let's check that. Yeah, the DB is ready. Yes, it's available. I'm gonna run this again. So the problem was the configuration for the security group. So here I show you that we need to add this root Postgres SQL type of connection port, but I choose the wrong security group. So if we did this here, choose launch wizard number 5, which was not the latest one. The latest one was launch wizard number 6, which is the security group that was automatically created for the EC2 instance that I created before. So this is the right one. If you save this, okay, there are no changes. And now I launched the same command. You can see MLflow will start initializing the database. In this case, it's a Postgres database. So, but this looks very similar to what we saw when we launched the tracking server locally using the SQLite DB, right? So it's initializing the tables and adding some metadata here, launching this server on this host. If we want to access the tracking server from your local machine, you just need to go to this instance, and here in the information of this instance you will find the public DNS. So copy this and then paste it here, and you need to add the port, which is 5000, and that's it. Now you have configured MLflow to run on AWS using SQL DB, which is a Postgres DB for the backend store, and using S3 for the artifacts store. You can share this instance with other data scientists. Let me show you how to access MLflow tracking server. So for that, we need to go back to Visual Studio. We are back to this notebook scenario 3, and we need to provide some credentials for AWS. Actually, I'm not gonna do that, just to show you, because this is a common problem also, that you forgot to configure your credentials. I'm gonna just paste this. Let's remove the HTTP and the trading slash here. And this is the public DNS of my EC2 instance. So I'm gonna set the tracking URI to HTTP, public DNS of the tracking server, and the port 5000. Let's execute this. Okay, if I ask what is the tracking URI, now it's pointing to this address. Make sure that this is a valid URL. For example, if you add something here like HTTP, and then when you ask for the tracking URI, you will see that this is not correct, so don't make that mistake. Okay, so now if I list the experiments, it will interact with the tracking server for the first time. So now this is gonna take some time. And you can see here it's saying that there is only one experiment. This is experiment 0, which is called the default experiment. Let's run also this code to train the model, create this experiment, add the run and metrics, and then log the model to MLflow. So it's taking a bit more time. If you remember, before it took 2 seconds, but now it's interacting with the remote server, so it's taking more than 10 seconds. And yes, this is the error that I mentioned before. So it's saying, okay, it failed to upload this requirements txt file. Basically, MLflow was trying to upload the model that we saved to S3, and it says the provided token expired. Okay, so it's basically that the credentials were not configured. Even though you launch the servers on EC2 and you configure the access of this EC2 instance into the RDS database and to the S3 bucket, you need to do the same on your local host because MLflow will use AWS credentials to access the S3 bucket. That's why it's important to, and I'm gonna just restart this. So it's important to provide this environment variable, AWS profile. I have already configured mine. I'm going to pass the name of my profile. Another alternative will be to pass the AWS credentials here, but I have used AWS configure on my terminal to configure a profile. So I just need to point to the profile and not need to pass the credentials as environment variables. Let's execute this one more time. And now let's see what happens. So again, this is going to take more time because now it's communicating to the remote server. Hopefully it will work. Yes. We can see that now the artifacts were stored to this folder. Let's check that. Need to go back to Chrome. And if we go here to S3, you can find the artifacts stored. And here there is the folder for the experiment one. There is this new run on the experiment one, and on artifacts, you will find this folder models. And inside, you can find all the information about the model, including the pickle file, the ML model file, and the environment. Okay, now I can list the experiments here. I can also here instantiate an MLflow client and list what are the registered models. So there are no models so far registered, and I can register one new model. Okay, so it works. And finally, let me show you just how it looks like on the MLflow UI. So to check that all these operations are being tracked by MLflow, so here you can find experiment number one. Let me enlarge this. And yes, the first run, remember that it failed because I didn't configure the AWS credentials. So I'm gonna delete this one. But the second run here was successful, and you can see it took around 10 seconds to finish. There is this model that you can see was stored on this remote artifact store in S3. Here you can find the artifacts and so, and also the model was registered into the model registry, which can also be accessed here. There is a version 1. Okay, that was it regarding the demo. Now we can continue with the presentation.